Part 2. Answer the first question and another 4 questions only. First question carries 16 marks and the other questions carry 11 marks each. So I will be doing all questions. Part 2. Question number 1. So recollect the activity that you have done regarding solids and answer the following questions. So this is from the textbook under 3D shapes, right? Grade 8 textbook. Question number 1. What is the name of the solid which has the pentagon shaped face that you have made? Right, pentagon shaped. So pentagon shape will contain 5 sides, something like this. 5 sides. So that one is the regular dodecahedron. D-O-D-E-C-A-H-E-D-R-O-N. Dodecahedron. Right. Part 2. Write down the Euler's relation regarding the number of edges, vertices and faces of a solid. So his relation is that number of vertices plus number of faces is equal to number of edges plus 2. Number of vertices plus number of faces equals number of edges plus 2. That's Euler's relationship. Part 3. Show that Euler's relation is true for a regular octahedron. In a regular octahedron, there are 6 vertices plus a regular octahedron has 8 faces. So this must be 6 plus 8. This must be equal to number of edges plus 2. So 2 is fixed. Number of edges in a regular octahedron is 12. So we can check. Number of faces is 6. Number of vertices is 6. Number of faces is 8. Number of edges is 12. 6 plus 8 is 14. 12 plus 2 is 14. The relationship holds there. Part 4. Draw the shape of a face of a regular octahedron and write the name of its shape. Right. So a regular octahedron will be made up of an equilateral triangle. So we have to draw an equilateral triangle. An equilateral for the octahedron. Lateral triangle. Equilateral triangle means a triangle with all 3 sides being equal. So what I can do is take any length and draw a straight line. So here I'm taking a length of 4 centimeters up to here. Then what I'm going to do is take the compass and measure what I can do is take the protractor. Since all 3 angles in an equilateral triangle are 60 degrees, put 60 degrees, draw an angle like this, and then from here another 60 degrees and draw like this. Then measure. This is 60 degrees and this is 60 degrees. Automatically we have drawn an equilateral triangle, the other one will be 60 degrees. And we can mark it like this. Right. Part 5. Name another two platonic solids which has the same shape of faces that you have drawn in part 4. So two others with equilateral triangles, we get the regular tetrahedron, and regular icosahedron. Right. Part 6. Write down the name of a solid which does not satisfy Euler's relation. So that will be cone. The cone does not satisfy Euler's relation. Right. Question number 2. In the pattern 1357, question number 1, subpart 1, write the next term. So each term is increasing, is 2 more than the previous term. So we can add 2 to 7 to get 9. Next term is 9. Subpart 2, complete the table to obtain the general term of the number pattern. So here 1 into 2 minus 1, 2 into 2 minus 1, 3 into 2 minus 1, 6 minus 1 is 5, 4 into 2 minus 1, 8 minus 1 is 7, and we got 9 earlier. So that is 1, 2, 3, 4, 5 into 2, 10 minus 1, which is 9. Subpart 3. Which term of it is 45? So 45 will be equal to that term into 2 minus 1. So we add this 1 back to get 46 is equal to blank into 2. Then divide 46 by 2 to get the blank, which is 23. So it is the 23rd. Part 4. When we add the first term, first two terms, first three terms, and so on, we get the first. We can get first terms of another number pattern. Write down that number pattern. Right. First term, first two terms. So we get 1, 4, 9, 16. Yeah, that is the square number pattern. 1, 4, 9, 16, 25, so on. That is square numbers. Square. Part 4. Sorry, that's the answer for part 5. It is, part 4 is that square numbers is the number pattern. Part 5, general term of the number pattern is, because it's square numbers, it's n square. Part 3, question 3. Subpart A. Figure shows a triangle made using rubber on a nailed board. Find the perimeter of it. So these two lines here indicate that these two lengths are equal. So this is 10 centimeters. And to get the perimeter, you have to add all three lengths. So that is 8 cm plus 10 cm plus 10 cm. That is 28 centimeters. Subpart 2. A square can be made on 4 nails using the same rubber band with the same perimeter in the triangle as in the triangle. Find the side length of it. So if the perimeter is going to be the same, the perimeter is going to be 28 centimeters. Then we are saying we're going to make a square. Square means all 4 lengths should be the same. So divide this 28 by 4 to get 7 centimeters as the length of a side. Part B. Figure shows a small stage prepared for an awarding ceremony. It is needed to paste a small ribbon around the stage. Find the minimum length of the ribbon needed for that. Right. So according to this, these are all made up of squares, each length 50 centimeters. So we can, around this stage, there are how many lengths of 50? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Again, starting from here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That is 50 centimeters multiplied by 10, which is 500 centimeters. If you want to give that in meters, since 1 meter has 100 centimeters, this is equal to 500 divided by 100, 5 meters. Number 4. Part A. Answer the following questions according to the information given in the figure. Part 1. Name a pair of vertically opposite angles. Vertically opposite angles here would be this angle here and this angle here. So that is EBC so the two opposite angles when two straight lines intersect. This one and this one. EBC and FBD. FBD and EBC. Part 2. Find the magnitude of DBF. DBF. So since they are vertically opposite, these two angles are equal, so it is 40 degrees. Name a pair of complementary angles. So at the beginning of the paper, we did complementary angles. Complementary angles are angles which add up to 90 degrees, right? So a pair of complementary angles are, we can say, DBF and DBF and FBA. Part 4 are ABF and ABD adjacent angles. ABF and ABD. So next part 4, are ABF, this angle, and ABD adjacent angles. So adjacent angles, I give an example, something like this angle and this angle, where they share a common vertex and a common side. But here ABF is actually a smaller part of ABD, so they are not adjacent angles. ABF is inside ABD. Right. Part B, find the value of x. So this is a straight line, and you know in straight line the angles add up to 180 degrees. So here 2x plus 4x will be 180 degrees. So 2x plus 4x is 6x. 6x is 180 degrees. So to get the value of x, we have to divide both sides by 6. So 180 divided by 6, x is 30 degrees. Part 5a. Right. Question number 5, part A. The length of a rectangular land is x and the breadth of it is 3 meters. A fence was fixed around the land by increasing the length by 2 meters. So the length has been increased by 2 meters while the breadth is unchanged. So we can the length has increased by 2 meters, so x plus 2 meters. Breadth is remaining at 3 meters. Right. Then this is subpart A1. Subpart 2, write an algebraic expression using brackets for the area of land covered by the fence and simplify. So area is x plus 2 multiplied by 3 meters squared. So that is 3x plus 6 meters squared. Part B. Simplify 3x plus 4y plus x minus 3y minus 5. So 3x plus x is 4x. 4y minus 3y is y plus y, and the 5 remains, negative 5 remains the same. Part C, subpart 1, simplify 3a into, within brackets, 2b minus 1. 3a into 2b is 6ab minus 3a. Subpart 2 in that, if a equals minus 1 and b equals 2, find the value of 3a into 2b minus 1. So here, substitute a equals minus 1 and b equals 2. Negative 3 into 4. Here 2 into 2 is 4 minus 1 is 3. That is negative 9 then. Question number 6, part 1. Find the highest common factor of 4ax and 6abx. So sixth one, HCF of 6abx 4ax. Right. So the factors of 4ax is four into a into x, and I can write 4 as 2 into 2 and then a into x. Factors of 6abx is 6 into a into b into x, and I can write 6 as 3 into 2 into, the rest is a into b into x. Now see the common ones. Is 3 common to both? 3 is not common to both. 2 is common, but only 1 2, so we cut one of the 2's. Both contain a, but both don't contain b, both contain x. So we are left with 2ax, 2ax. 2ax is what's common to both, so the HCF is equal to 2ax. Six part 2. By taking the highest common factor as one factor, write as a product of two factors. Right. So we have 24ax plus 16a squared b plus 8a. So for each one, 24ax, 16a squared b and 8a. From this, we can write this as, I can take 8a out, 8a into 1 here, 8a into ab, sorry, 8a into 2ab, because 8 into 2 is 16, a into a is a squared and b. 8a into, clear right again, 8a into 2ab will give 16a squared b. And here 8a into 3x. So the highest common factor is 8a. Right. So then I'll take 8a out. It will be 3x plus 2ab plus 1. 24ax plus 16a squared b plus 8a. Subpart 3. Write as a product of two factors minus 5x minus 20y. So here take minus 5 out. We get x plus 4y. Minus 5 into x is minus 5x. Minus 5 into 4 is minus 20. Y. Part 4. Fill in the blanks. Minus 6a plus 8ab equals minus 2a in the blank. So from minus 6a, if I take minus 2a out, the remainder is 3. Because 3 into negative 2 is negative 6a. And here negative, here positive. So to make it positive here, I have to make it negative here. Negative into negative will give the positive. From 8, if I take 2 out, remainder is 4. A is already out, so B. Negative 2a into 3 is negative 6a. Negative 2a into negative 4b is positive 8ab. Question 7, part A, fill in the blanks. "3.5 tons in kilograms. 1 ton equals 1000 grams, 1000 kilograms. So multiply this by 1000. 3.5 into 1000 is 3,500. Similarly, to convert this into tons, divide this by 1000. 1, 2, 3, 1.6 tons. Part B. Mass of a container loaded with rice is 10.25 tons. Mass of the empty container is 2 tons 500 kilograms or 2.5 tons. Packets of rice with a mass 10 kg is needed to be made from the rice loaded in the truck. How many such packets can be made? Right. First we need to find out the weight of rice. So the loaded one is 10.25 tons. Empty container is 2.5 tons. Subtract that and we get 5 minus 0, 5, borrow 1, 12 minus 5, 7, 9 minus 2, 7, 7.75. So 7,750 kilograms of rice are there. We need, one packet will contain 10 kilograms. So divide this by 10, you get 775 packets. Part C, simplify 17 tons and 200 kilograms divided by 8. So 17,200 kilograms we divide by 8. How many 8s in 1? 0. How many 8s in 17? 2. 16, 1 remainder. Bring the 2 down. How many 8s in 12? 1. 8, 4. 40. How many 8s in 40? 5. 40, 0. Bring the 0 down. 0, 0. 0. 2,150 kilograms or 2 tons and 150 kilograms. And that's the end of the paper.